Okay, so to continue our question, we're going to use the same standard formula. We're going to concentrate on A first. So first of all, my interest rate in this question is 9%. However, we are compounding monthly, so that means we have to divide the 9% by 12. So my new interest rate is going to be 0.0075. Now, whenever you're doing finance problems, you cannot round. Do not round that to 0.008 because you will not get the right answer. And my N, which stands for the number of compounding periods, is the number of years, 4 years. So because we're compounding monthly, each year is divided into 12 compounding periods. So we have to multiply the 4 years by 12 to get the number 48. And now we can plug this into the simple form of our formula. So A is going to be equal to T times 1 plus I to the power of N. Let's see if I can extend this for a second. Okay, let's continue this on the next page where there's a lot of room. Don't know what's happening here. Okay. So I know that my P is $5,000. That's the amount that she borrowed. And 1 plus my interest rate is 0.0075. Rewrite that with more room, 0.0075 to the power of 48. So remember, you're going to punch this into your calculator first, and when you do that, 5,000 multiplied by, for this particular question, let's try it with 4 decimal places, 4314, to get a total of $7,157.03. So this is the amount that Rukshana must pay, or repay, I should say, after 4 years. Now the next question is something that pops up frequently in your unit guide. How much of the amount, the final amount that she repays, will be interest? So if my initial amount was $5,000, how much of the final amount will be interest? So the formula that you always use when doing this, interest, or your total interest, is equal to your A subtract P. So my final amount subtract the initial amount that Rukshana borrowed. That's going to be equal to $7,157.03 subtract $5,000 and that's equal to $2,157.03. So this is the amount she will repay in interest. Okay. Now we have to move on to a different formula, which is the present value formula. So before, we started off with A is equal to P times 1 plus I to the power of N. Now, principal can also stand for present value of the loan. So if I want to solve, instead of solving for my final amount, if I want to solve for my present value, basically I want to isolate the PV. So that would involve dividing both sides by 1 plus I to the power of N. And that gives me P is equal to, or PV, the present value, is equal to A divided by 1 plus I to the power of N. Now this form of the formula incorporates the whole idea of compounding periods. It's a more complicated version, but for your unit guide I'd prefer you to use, and in your textbook I think it shows you, the simpler form of the formula, this form. Or we can rewrite this as present value is equal to A times 1 plus I to the power of negative N. So let's do a question using this new formula. What principal should be invested today to have $1,000 after 2 years if interest is paid at 4% per year, compounded quarterly? So first of all, I'm going to focus on my interest rate. Interest is equal to 0.04 divided by 4. And that gives me a final interest rate of 0.01. And my N is going to be the number of years, 4 years, multiplied by 2, which gives me an answer of 8. So once you figure out your compounding values, then we can plug everything into the formula. So present value, or the principal, remember P stands for both terms, is equal to A over 1 plus I to the power of N. So P is going to be equal to 1,000 divided by 1 plus 0.01 to the power of 8. Now remember, the calculator is not as smart as you are. So instead of punching everything in all together, try to keep your numerator and denominator separately. So I'm going to try to punch in my denominator by itself and figure out that value. And we're going to keep all our decimal places again to get the most accurate answer. 2856706. And now when you punch this all into your calculator, you get $923.48. So that means this is the amount that you have to invest today in order to get $1,000 at the end of 2 years.